Okay, now that we're into week 6, I thought it might be a good idea to do another video that kind of builds on some of the R videos that we've got up on the Moodle page already. So we'll just say that this is more basic information on RStudio. So there's the RStudio startup window. You've installed both R and RStudio. And as you've seen on the other videos, everything in R begins uh, with that prompt. And it's a prompt that you enter multiple times in an R session generally. Uh, R, incidentally, can be used as a simple calculator. Not really the most practical calculator, but obviously it has all the capacity to do uh, calculations using the typical rule of order of operations. Uh, you probably remember, please excuse my dear Aunt Sally, which is parentheses, exponents, multiplication, division, addition, and subtraction, right? That's what you should follow in, calculus, algebra, and generally in R. But as I said, R is not a great, in terms of convenience and intuitiveness, calculation tool. But I put this up here because it also, I deliberately made a couple of errors, and error messages are quite common in any R session. I took a course in computational statistics a couple of years ago, and the professor who focused on R and had written R packages that are used, and he's got some renown in the field, was uh, he did videos of him doing R, and he was always making errors. So I figured that it was part of the game, and I guess it is. So I did this first calculation: 2 minus 3. Hit enter, you get -1, right? Makes sense. But 2 times 737,298,000 got me an error. Why the error? Well, it says there unexpected symbol. That simply means that the times symbol that we use, we think of that as an X, was a mistake on my part because we use the kind of the star, the little character above the 8, right? So re-entering it, I get the 2 times 737,298, and I get 147, well, whatever, you see it there. Now, what happens in the next one? I get another error. Well, that's because I put a comma in. Commas are used in R to separate parts of arguments or parts of vectors. They're not used in numbers. So that's why it gave me that long 147,000 number without a comma. And then when I tried to use a comma again in the next equation, it returned an error message rather. So one thing I would urge you to do, and you've indeed been requested in the first R homework assignment, the data assignment for week 6, is play around with some vectors. You can create them in a couple different ways. The one video we have up there already shows a vector quite similar to the one I've done here. I created a vector that I gave the name x. Then there's a little operator which looks like the less than symbol, or is that the greater than, with a dash. That's always what you use to assign a value to something. And I then enter x, and I get the exact vector between 1 and 14. That's one way to do it. Another is, here I'm naming the vector b, and I'm showing you have to use the C in front of parentheses, and then you can just enter your numbers. I then enter B at the prompt after I've already done that, and I get the exact numbers that I've entered without the commas, because the commas are for your command to R, not for R's output to you. So I decided you can do a summary of any object in R, obviously, and that's covered in one of the videos that we've already got up there. One thing you'll notice when you start to type things like summary or anything else is that R will start to fill that out for you and then summarize what the function does. So that's one of the helpful features that RStudio brings to the whole R party. So anyway, I did summary, and we see there summary, the minimum is 1, the maximum is 99. We see a mean and a median that are six numbers apart, which is a lot for a tiny data set. So generally, a rule of thumb, so to speak, in statistics is that means and medians close together is representative of a balanced data set. So so then as you see there, I pasted the same vector below that, and there's the 99 that was the outlier, and I changed the 99 to 29. So, and once you do that and hit enter, you're changing the entire value of a vector. So you can change the contents of an object that you create, and it becomes, it loses the value that it was once assigned. R reassigns it whatever you have in there. So, and you see the same vector entered again. That's easy to do. Whenever you want to repeat a vector or something that you've just typed above, hit the up arrow and it will repeat it. That comes in handy if you discover you made an error and you just need to correct one or two things. Hit the up arrow and you'll get a repeat of that. So I summarize after changing the 99 to the 29. The next summary produces a mean and a median that are much closer together. So we saw that the outlier in that case, the 99, is what caused the great distance between the mean and the median. Another thing we're going to talk about briefly is importing data sets, because you do have data set importing to do, especially with the final project. And I think I mentioned this in an earlier video, but you'll click import data set. And in this case, I had a data set of housing starts from probably the Department of Commerce. All housing starts, number of housing starts in the U.S. between January 1st, 1959, I think, and June 1st of this year. So it's, I think, 700 and some months. Anyway, I found the data set. I clicked import. This is kind of a last interim window where it gives you a look at the data that's in the file. You click import, and then you get kind of, it looks like kind of like Excel columns almost there up in the top left of the R window. And you'll notice down there at the bottom, R has basically repeated what it would have. Instead of you normally having to type that stuff, you could have typed it down there. R kind of repeats what has happened based on you clicking that. So it does have RStudio does add some point and click attributes, but a lot of the work with R is entering code, so to speak. So there's the left side of the RStudio window. Before you attach it, you next have to attach. That means basically putting it into your R workflow. So this data set was called HOUST, HOUST. It was actually HOUST.CSV. It could have been HOUST.XLXS, but it was HOUST.CSV, comma separated values. And there's sometimes error messages. The red type can be relatively benign. I found that to be the case here. It says the following object is masked by global environment, HOUST. And I believe that's because the data set was named HOUST, and one column, one object in that data set is also called HOUST. So I think that's what happened there. So the string or the str command is something that can be used to basically describe everything that's in the data set. In this case, it's just dates and monthly housing starts for the entire country. It says, okay, so that tells us that there have been 726 months since 1959. Wow. 726 observations of two variables, the dates being one variable and the number of housing starts. A long and large data set that's that's actually fairly simple in this case. So it kind of shows you what to look for there. Another thing you can do is head. That basically gives you the first 5 or 6 instances in the data set by row. So it's, in January of 1959, there were 1,657 housing starts. The following month, there were 10 more, actually. So it actually lists the number of housing starts nationally. So it's a good way to preview the data with the first rows. I'd like to refer you to the Base R cheat sheet, which is on the Moodle site. It's got a lot of little things that you should probably do once you have a data set, or with taking an object in the data set, or with the vector you create. Just to play around with it and see the different things that R will do. For instance, you can, the sort function. In the case of the B vector I created a few slides back, it would sort that in order rather than the random way I gave it. If I did sort parenthesis B end parentheses, you always have to close your parentheses. Or it would reverse the way I ordered it if I typed rev parentheses B, and so on. There are other things too that are kind of valuable, like class. If I were to enter class B, it would return the remark, probably numeric, I would think. There are 5 basic classes in our character, which are words, numeric, which is any number, positive or negative, integer, which is a whole number, positive, logical, which are things like true, false, yes, no, male, female, and then complex, which few people get into the complex in most R operations. So a very handy one of those, as I think I've mentioned, is to use summary. Summary basically gives you the key statistics about any data set. In this case, it's giving me the summary for the whole data set of HOUST. Not real valuable on the date score, right? But when you look over on the HOUST object within that same, the best thing, if I've mentioned to you pre-processing, the best thing for me to have done would probably be to name the object something other than what was provided with the government data set here. I should have just called it HOUS maybe, just so that it's different from the name of the data set. Anyway, it gives me a minimum of 478. That must have been a recession year. And a maximum of 2494. Summary is very important to use with almost every R session that you do, just because it gives the quartiles, it gives a mean, gives a median. We see here 1455 is a median. That's the in-between number of the whole range between 478 and 2494. And the mean. And given a data set that size, you see that it's pretty well balanced. There's only a difference of 25. So that's percentage-wise, that's pretty good, or it's indicative of a balanced data set. Not everything you do with R that is produced is particularly meaningful. I decided just to box plot HOUST, Hoost, and that's what it gave me. It didn't give me an error message, it gave me that. Well, it's putting two different counts on the same plane here, and so you can't really tell what's going on. One thing that did produce value in terms of this quick R session I did with this quickly found data set was I tried just a simple plot. And there's what it gave me. 1959 all the way to last month, even though it doesn't show it down at the bottom there. Statistical plotting is looked at in terms of explanatory and response variables. Explanatory is basically your x-axis or your horizontal axis, and that is basically the explanation for what's happening or what's being tracked. The response is a numeric response, and that's on the kind of the y-axis. I remember explanatory because I associate it with x-axis in my mind. Anyway, so in this case, dates are the explanation, the simple unraveling, unfolding of time over 50, 60 years or so. And we see the each monthly instance is a dot. Remember a slide or two back where we saw in the summary, and you can go back there and look if you want, was something around 2400 was the max. Remember that? Well, there you see it, and it's above where the 1977 starts. But if we think about this logically, it was probably in the late 60s, early 70s. That would be easy enough information to find if we wanted to go in depth. So that's all for this.